Okay, so ANUA basically was started in North America back in 1993. It was started back then as Bord na Móna, which is an Irish company. And Bord na Móna has a long history over in Ireland, involved in a number of ventures, energy, horticulture, refuse, a whole bunch of different things. Recently, we, Charles and myself and a group of equity partners in New York State actually acquired ANUA from Bord na Móna, so that's actually exciting news for all of us. And we have a long-term contract in place for Ireland to supply peat fiber to us, which you're going to learn about the peat fiber today in the Puraflo system. So basically our business is segmented in two ways. We have the clean water and the clean air. Our goal, we look at all water as water. We try not to use the term wastewater because especially in situations like California where all water is necessary. So our goal is to look at it all as a resource, look at the things that are there, how we can treat it, and actually capture, treat it, and then make it usable for the owners on the property. On the air side, we do odor and VOC control, which obviously we're not going to cover any of that today, but just be aware that that's another segment of our business. And so whether it's sewage lift stations or small package plants, we actually do projects for that. We currently have a project underway at the City of San Francisco with the shell-based technology for odor control. All right, on the next one. Or do I have?
We actually have a poll question coming up here for our attendees. So I'm going to launch that poll. And I'm going to give our attendees a few minutes to answer the questions. So I'm going to share the answers. Now I'm going to close that poll and share the answers. Hopefully it's not, but it doesn't look like it's sharing. Right now we've got 11% say that water reuse technology is somewhat important, 67% say very important, and 22% say extremely important.
Okay.
So we can move on, and we have a second poll now. So we'll give them a couple of minutes to answer this question. Okay, I'm going to close this poll now and share the answers with you. The question was, does your local regulatory agency require a service contract on advanced treatment systems? 57% said yes, 29% said no, and 14% said it was part of their new lamp.
Okay.
So we'll move on. Are you there, Colin?
Yep, okay. Well, it's waiting for it to come up. So peat, we actually use peat fiber from Ireland, which we're going to talk to you a little bit about. But you can see the graphic on the graphic image on the right. It shows you how peat is formed in a bog, which is basically like a wetland type system. So over time, which is thousands of years, the wetland will actually fill in with the peat, and the picture doesn't show it, but you can actually cap off and kind of crown up and actually create conditions where it actually makes it unhealthy. So, but what you're going to learn is there's all different kinds of peat. So if you go down to Lowe's or Home Depot, and buy a bale of peat for your garden or your shrubs or flowers, that is not the same thing as what is going to be used in an on-site treatment system. And so we're going to learn a little bit about the differences of that. So we try to explain to people there's a difference between sphagnum, peat moss, and then peat fiber. Okay, move on. So if you look at this image, it shows the edge of a bog in Ireland, and you see the little white plants that look like little cotton balls, and so it literally is referred to as bog cotton. And this grows along the edge of the bogs, and basically over time it washes in and accumulates, and then that actually, when they go to harvest sphagnum moss, is actually a byproduct. They screen it out because they don't want it there. And then, so if you look, why is the fiber a superior treatment medium? So we compare it to the North American peats, whether it's fiber or sphagnum, you'll see that the lignin content is twice as much. So one of the common questions with peat filters is how long does a media last? You know, because it's an organic material, and over time it will slowly decompose. So with the high lignin content over 50%, the Irish peat will generally last about 15 years. We've had many systems that have gone over that. Sometimes systems go less than that, but on average we say 15 years. And if you compare that to the different North American peats, then it's about twice the lifespan. So a lot of times you'll see from other manufacturers, it might only be 7, 8, 9 years, something like that. So there's been a lot of studies that were done actually in the late 90s and the early 2000s. If you've been in the industry a long time, you can remember the 90s was a time when there was a lot of research going on. A lot of universities were involved in different research. And so the University of Minnesota, where they actually have a lot of peat resources, actually wanted to study all different types of peat and do different configurations of peat filters to see how the performance compared. And so the summary of all that study, which actually lasted 5 years, was that the coarse fibrous peat was actually the most preferable. And of course, like all media filters, we always have a balance with any media filter, media system. We're trying to maintain oxygen transfer as well as move the effluent. So it becomes a game. If it moves too fast, then we don't optimize treatment. We don't have time to do what we need to do. If the pores are too small and it moves too slow, then that leads to clogging, which if you've ever dealt with different media filters, whether it's even a mound system as a media filter, sand filters, you've probably witnessed clogging of those filters. You can even think of soil as a media filter even in a conventional system. So, one of the things that's great about the peat fiber is it maintains those air spaces and channels. And as you see here in a minute, the next slide, you'll notice how the properties of it facilitate both of those. So we retain water 36 to 48 hours, which of course is much longer than most other types of media. And you'll see later that's one of the reasons why you get really good pathogen removal as well as very high ammonia removal. The void space, of course, is very high, well over 90%. There's a high surface area. And then the big kicker with all of it is the cation exchange capacity. So with a natural media, it actually is charged. If you think of, you can go to the store and buy air filters that are hydrostatically charged. They're there to grab particles out of the air as it goes through the air filter and attract it to it. And the same is true of a peat media. You're going to attract and hold molecules so that it actually can be further transformed or will actually be adsorbed and bound. So if you compare, just to give you an idea, when you look at that scale of 125 milliequivalents per gram, that's a very high number. So if you compare that to sand, like a very sandy soil or just sand, like concrete sand, that would be very low, like single-digit numbers, like probably 0 to 5, somewhere in that range. So we got a little video here for you that is going to show you an overview of how one of these systems works. All right, so you see the overview, bird's eye view. So basically we're just going to start with a conventional septic tank. These are typically going to be sized to state code or county code, whichever, or local code. And so obviously we want it to be watertight. That's critically important. You'll see that this is a time dose system, so that if we don't have a watertight septic tank, obviously in addition to treatment problems, it's going to create other problems for us as well. And then that flows into a time dose pump tank where we typically are going to dose once every 2 hours. It's a single pass system generally. We do have recirc options available if you need enhanced nitrogen reduction. But normally, typically we're going to use a low head effluent pump is all you need, because the most that pump's going to be running in a day is maybe 12 minutes or so. And then you're going to dose the peat fiber media. You see the manifold there, and so the pressure point is actually the little union there. There's a 1/2-inch orifice disc, and that's where you're actually going to design to pressurize. So in this case, if you have 2 modules, it's equivalent to pressurizing 2 1/2-inch orifices. And then you'll see this shows the piping method. So if you had a separate dispersal field and you went out to, say, gravel trenches or chambers or something like that, or if you wanted to collect it to pump to drip, then you would use this methodology. The more popular method that we typically see is with the weep holes, where the base of the module has weep holes all around it, and we have a gravel pad underneath it, so the modules are actually sitting directly on top of the drain field. And then one of the things we always try to advise people is to have the sample chamber. We want to be able to see the effluent. We want to be able to sample it if necessary, and so it's critical that you have a way to do that.
Oops.
All right, so the first part of it, first part of a system is a septic tank, as we mentioned, so watertight, size to code. The next key component is the commercial effluent filter. So we've had commercial effluent filters in our systems for over 20 years. We found one of the questions we get is 1/32 filtration is very small, and have you seen issues with those filters and clogging? And fortunately, one of the things we have is experience of time with this system. And so the commercial, because they're a commercial filter and they have a lot more area than like a 4-inch filter, then we see the maintenance frequency goes pretty long on these, and also you get the better filtration. So there's just a list of the companies or models that are 1/32 filtration. And then the pump tank, again, this needs to be watertight. One of the things that we do is we have a separate pump tank from the septic tank. One of the nice things about this we found over time is that you just don't deal with the nuisance high water alarms that you might with other systems that tend to combine everything in one tank. So when you have all that surge volume, it's really nice for when they're having parties or people over, that type of thing. So typically, like we said, it's going to be dosed 12 times per day. That's only if the flow is there. So in a low flow situation, it may not even be 12 times a day, but it's going to be a 2-hour off cycle. And the key part of it is just to separate in your mind the dosing rate and the dosing volume. So each module, which you're going to learn about here in a little bit, is 7 to 12 gallons per minute for the pump, and the dose volume is 5 to 15 gallons per dose per module. So those are two ranges of numbers you need to be familiar with if you design a system. The other thing we like to do is have no override, and we do that for a few reasons. Is if you override a system, obviously you can throw a lot more water through your treatment and onto the drain field. That's not a good thing, because you don't optimize the treatment. And then also, really, it's a violation of the permit conditions, because most permits are rated at a max flow per day, and you could end up with an override situation where you might be putting thousands of gallons a day through a system potentially. So we highly discourage use of override floats in the system. All right. And that's just just shows you a general picture of how we would see a pump tank set up. Now, some people get a little creative. I mean, you can combine, like Jensen, of course, is a big concrete company. They have the ability to manufacture the septic and pump tank into one tank. I don't think that's an issue for them. Most of the time, though, you'll see them as separate tanks. But it's a really basic setup, low maintenance, not a lot to deal with other than the floats working and making sure the pump works. This is a view of the module. So normally when you open it up, you'll look like how the right side of it looks. You wouldn't see the distribution manifold, but you can see on the left the distribution manifold, how that's set up. You'll see one of the stabilizer bars there that the manifold sits on. So Basically, effluent's pressurized from the bottom. You see the little hole, the Schedule 80 fitting at the bottom, which is 1 inch. And so you're going to bring the pressure line in there. It's going to come up through the module on the inside, which protects it from freezing conditions. And then the manifold there on the top. So we'll see here in a minute, but each one of these modules in a residential effluent strength, you're going to treat 150 gallons per day. As we mentioned with the cation exchange, one of the nice things about the peat fiber treatment is you get all 3 types of treatment. So all the alternative systems or advanced treatment systems are going to typically do biological treatment. That's kind of a given. And then when you get into the media filters, you also get the physical filtration and absorption. And then the peat, you get the third benefit where you get actually chemical treatment, where you get adsorption and ion exchange. So it's probably the only technology, these natural media filters, that actually give you all 3 types of treatment. And so one of the things you'll see in these is it's not uncommon if you're doing maintenance to see higher life forms inside the filter. So one of the nice things is you get beyond just the foundational level of bacteria performing the treatment. You move to higher chain organisms that are actually better at treatment, and they produce less waste, and so that actually is a benefit. And so you have a lot of biology going on there. You'll see a lot of bacteria. You'll see fungal species, different things of that nature. And then, of course, most media filters, as most people probably know, the top portion is where you're going to do your carbonaceous breakdown. So normally in a chain of converting or utilizing, it's carbon, nitrogen, and phosphorus. So that's why you're going to see carbon come out in the top part of a filter, and then as you get in the bottom, the nitrifiers are going to populate that because they can't compete with the organisms that take care of the carbonaceous waste. So typically the deeper parts is where you'll see nitrification, and then in peat filters you'll see little pockets or microsites where you'll have anoxic areas, and that provides denitrification because you have an organic source there available. So even in single pass, we'll typically see nitrogen removal anywhere from 25 to 40%. And then when we go in recirc mode, you'll see nitrogen reduction levels upwards of 70%. Hold on just a second. You have to excuse me. I'm up in Ohio here, and there's something blooming that's really hitting my allergies. So one of the real benefits that sets peat filters apart is the antimicrobial properties, or what you would call microbial antagonism. So with that retention time of 36 to 48 hours, you have a long time for stuff to work in there. The peat is going to lower the pH, so that lower pH, as we know, is going to have an effect on the pathogenic bacteria and viruses. And then also with the fungal species, you're going to have some benefits there. So what we see are very high levels of pathogenic bacteria removal and 100% removal of viruses. Now, when we were really researching this in the beginning, if you go all the way back to the 80s and early 90s when this was researched, they actually did tracer studies and different things, and one of the studies that was done was on these pathogen removals, and it showed very high levels like what you're seeing there. So there was a study done in Minnesota again later in 2000, and just for disclosure, this was not actually the peat fiber from Ireland. It was another peat that they used from Minnesota, but it just demonstrates the difference between peat and sand in terms of removal of viruses. So you see that there's virtually 100% removal of viruses both summer and winter. Of course, in Duluth, Minnesota, they're very, very interested in how systems perform in cold weather because they have cold weather 8 months out of the year. And then if you compare that to sand filters, you'll see there was a drop-off in the wintertime. The other interesting thing, if you go to the next slide, is it shows how long it takes for virus inactivation. So in peat, you tend to see virus inactivation in less than a day. And if you compare that to sand, it takes upwards of 23 days plus to actually see over 90% virus inactivation. So this stuff's all very interesting because we try to talk to people kind of about the beyond BOD and beyond suspended solids in terms of treatment. We want to get into other things that we discuss, and it becomes very important in water reuse to know about pathogens, to know about nitrogen and these other and emerging contaminants, you know, it becomes important to know about those things depending on how the people are going to reuse the water. So we've been through NSF testing. That was certified in 2006, and you can see the effluent averages of 2.2 BOD TSS. The one that we always like to point out is the maximum. If you get any test booklet from any manufacturer, it's interesting to look at the maximum column. So you can see there were some very high influent values for BOD and TSS, and yet the P filter and the Puraflo never exceeded 1010. And so we generally expect to see less than 1010 treatment out of this, even in field sampling. So we've been part of a number of third-party studies all across the country. A lot of these took place in the late 90s and, like we said, early part of 2000. One of them was in Ohio, down in Claremont County, which is outside the Cincinnati area. And it was funded by the Ohio EPA as a grant project. And they had 8 systems that were actually Puraflo systems, followed by shallow profile mound systems. And you see the next couple slides here, we'll see the results. So the first one is the fecal coliform. The P filters were the only ones that 100% met the limits of the sampling limits that they had. And in this case, the sample limits that they had on fecal was 2,000. And you can see there was a suspended growth ATU, fixed film ATU, and an intermittent sand filter. And you can see the difference there in the graph. The next one was ammonia. So Ohio is a big direct discharge state. They do a lot of surface discharge to ditches and streams, and so they're very worried about the ammonia. And again, it was the only system that 100% met the samples. Currently in Ohio, those numbers are very low. I think back at the time when this took place, it was 2 and 4, 2 in the summer, 4 in the winter. And you can see the difference between the Puraflo and the other technologies. And in the drip distribution guidance document that the Ohio EPA published, they actually have this statement, which is, we found this a few years ago, which is very interesting. It talks about discharging in sensitive water sets, because it's not uncommon to get water tables up here in northeast Ohio that may be 6 to 12 inches below the surface. And so they don't want to obviously put chlorine in those situations, so it discusses other types of disinfection methods, and one of them it lists is P biofilters, which is very interesting. So the next part, we're going to move on to the soil and the drain field. So we like to talk about that the Puraflo is actually the circuit breaker or the fuse between the drain field. So what you don't want to have happen is your treatment system not perform reliably to the point that you still end up plugging the drain field or having clogging issues or hydraulic issues. So we feel it's very important to be able to manage that, and Puraflo allows us to do that.
We have another poll question here, so let me open that up for everyone to see. And the question is, in your local market, do you see more opportunity for repair work or new construction? So I'll give our attendees a few minutes to answer that. Okay, it looks like all the answers are in, and we have 29% of our audience saying repair work and 71% new construction.
Interesting. All right. So now we're going to talk about Puraflo combined with a drain field. So this is the way that allows the homeowners and the people actually using the system, the operator, to have a very simple system. It's robust, and we're going to have drain fields with very little to no issues. So you can see here, this shows how the drain field is underneath the modules. This is what we would call an in-ground pad methodology, because the gravel is actually in the in-situ soil. And so this also gives you a profile to look at, septic tank, effluent filter, time dose pump tank, going to modules. So of course you'll have multiple modules depending on the flow. So a 450 gallon per day system, you would have 3 of the modules. And then the drain field is just sized based on your loading rates for treated effluent. And just so you know, we have design tools, Excel design tools that will help you with all this. It'll design it for you from the septic tank all the way out through the drain field. So that makes people's life easy. So then moving on to the next slide, you'll see, so this is a site up in Minnesota. This is typically, obviously you don't see the septic or the pump tank, but this is a typical configuration where you would have the gravel, what we call the pad, the in-ground pad beneath the modules. Just ignore the color of the gravel. This particular gravel is tan for some reason, but I know most people's is gray. And then you would just space the modules evenly throughout that pad, and then you have the pressure manifold coming in, supplying the modules from the time dose pump. So it's really simple. So everything will be backfilled, and you'll see some pictures here in a minute. The only thing that is on the surface is the lids, which are accessible for the service provider to be able to see what's going on in the filters. So this site in Alabama is typical of the situations we get into. Heavy slope on a lake, no room. Matter of fact, I just worked with an engineer in Mississippi that worked on a site with a 45% slope. They notched into the 45% slope hill, cut out a bench for the house and the Puraflo system, and then that was it. So we deal with what we like to call extreme sites all the time. So that you see the modules in the front yard with the gravel beneath it, that is the treatment and the drain field in that small space. And then here's a site in New York. So it's interesting, the poll that we took. This is a repair site, and that's all the space they have is next to the house in between the street. And so that is the modules with the drain field. That is your treatment and dispersal system right there. One of the questions we get is about landscaping, but this demonstrates in North Carolina, coastal North Carolina, where you have sites, very small lots, sandy soils, so you don't have to worry about dispersal so much. The water will go away too fast, actually, which is good to have peat because you treat the pathogens and the nitrogen. But you'll see how they nicely landscaped it. So there's ways to landscape around the lids if there's a concern with that from the homeowner. And then you also see the sample chamber there so that the service provider has access to sample. So now we'll talk about mounded pads. So those of you that are familiar with Wisconsin mounds, where you have, you scarify the native soil, you lay some sand down, then you have a gravel layer, and typically you would have then a pressure manifold there supplying from a pump tank that's with septic tank effluent. So what we do is we put the Puraflo modules instead of the pressure network. Now you have treated effluent going into the mound system. So your mound ends up being smaller because the soil application rate's higher, the sand loading rate's higher, and the vertical separation is less. So if you get in situations where you have very shallow soils and limiting layers, high water tables, maybe you have bedrock at 12 inches or 24 inches, then you can elevate the modules up out of the ground and build a mounded pad out of it. And here's a site in New Jersey that you see, and they did some landscaping with some rock. You can see how this is elevated above the ground and in a mounded application. And this is here in Ohio, this really gives you an idea of what the difference is. So, and I know there's counties in California that actually do mound systems. So the one in the background is a house that's on a conventional Wisconsin mound. So it'd be septic tank, pump tank, then sand mound. And then in the foreground is the mounded pad. So it's the Puraflo with the gravel, then a little bit of sand. And so you get to see the difference of what doing the treatment does. It cuts down the size and the height of the mound greatly. And so if you're familiar with Tyler table and linear loading rate and spreading the effluent along contour, we design to all those factors. And you see here what the difference is. And that's how we're approved in Ohio as an example. So we have to follow that stuff. And this just gives you a really good visual of what the difference is. So it just so happens that we've had the pad tested as well. So you saw some treatment numbers earlier where what the treatment was through the peat biofilter, and now we can show you some data when you get down into the gravel pad and then into the soil profile below or horizontally away from the gravel pad. We can show you some numbers here. And so the first one you'll see is the fecal coliform. So if you look in the sample chamber, which would be actually through the Puraflo, it was 290 was the number, which of course is, most people know that's almost full body contact in the water. That low of fecal coliform. And then once you're in the pad and then below it or down gradient, you can see the numbers below 200, below disinfection level. And then this one really demonstrates the treatment efficiency and also the effects of denitrification in soil. So one of the questions a lot of people have is, how much does soil denitrify? We think it does. We know it does. If you dose it, you do it shallow. And we have some quantification on that. So one of the first things that stands out here is the difference between the pump tank and the sample chamber after you've gone through Puraflo is that you have full nitrification. You can see the ammonia, the NH4N is very low. It's 0.4. So we have full nitrification. That means we have a really good, robust, well-operating filter when we see those kind of numbers. And this is typical of what you see out of Puraflo. Not always down to 0.4, might be 0.8, might be 1, might be less than 2. But we generally see very low ammonia numbers coming out. And then what's really interesting when you get to the nitrate, the NO3N, if you go right when you get in the trench in the pad, you see there's a huge drop in that number. So what we see in the pad and then below the pad and down gradient is we see significant denitrification going on. So one of the studies we had done, we had 24 sites that were tested from July 97 through 1999. And some of these were actually commercial sites. They weren't all residential. So some of them actually had some very high ammonia or very high total nitrogen, very high BOD. And they tested not only the Puraflo treatment system, but this was also a test of the pad. So one of the things we had to do in Virginia was test it in all the different soil groups. So Virginia broke it down into 4 different soil types that they wanted to see, and we had systems in all those different soil types. And of course you can read the quote there at the bottom of the paper. And just so you guys know, any of these papers that we've shown in here, any of those are available if anybody wants copies of them. So as part of the Virginia study, this data is actually sitting at the U.S. EPA right now. There's actually a subcommittee dealing with the Chesapeake Bay situation. All the Chesapeake Bay states are grappling with the nitrogen. They all have to get it reduced. And so on-site systems obviously are one of the places that impacts that have to do reduction. And so the state of Virginia has actually submitted this to this committee at U.S. EPA. And one of the things we're working on with them is getting the combined treatment and soil dispersal system recognized for the full nitrogen reduction that it does. So what you'll see is it's about a 40% nitrogen reduction through Puraflo, and then from Puraflo through the sample chamber in the pad itself, there's another 58% reduction. And then by the time you get 10 foot down gradient, you're looking at really significant denitrification numbers down in the single digits. So keep in mind that these systems are all very shallow. So I know sometimes in California when you get out west, I used to work in Arizona and live there. We tended to do things deeper, down below 2 feet. So one of the tricks to getting the enhanced denitrification is you got to keep all this really shallow in the soil profile, typically less than 24 inches. Definitely not deeper than 36.
We have another poll question here, so let me pull that up. And the question is, which of the following are you most interested in learning more about? And you can select all that apply here. So let me launch this. Sorry about that. There we go. Okay, it looks like everyone has given us their answers. And it looks like 67% are interested in operation and maintenance, another 67% in installation procedures, 67% in design criteria and tools, 22% in case studies, and 78% in performance data and reports. So thank you for answering those questions. It's really interesting.
Yeah, that is interesting. So I want to talk a little bit about commercial Puraflo. So up until this point, most of everything that you've seen is residential. So you'll typically see a septic tank, pump tank, probably anywhere from 2 to 6 modules is typical for most residential applications. But we've done a significant number of commercial sites. And so for small commercial sites, especially things that are going to be intermittently used, it's a very good system to choose. So I'm going to show you, although it didn't sound like people were interested in case studies, we're going to show a little bit about applications. So,
Colin, we do have a question from Dylan, and the question is, for multiple pods distributed directly on a gravel bed, do you recommend a sampling port on each pod for effluent sampling?
No, there's just one sample chamber in each residential system. So it comes out of one of the modules because they're all dosed at the same time, and they all have the same media. So you're just getting a snapshot out of that system. If you need more information, Dylan, go ahead and send Marcia a note. We'll try to clarify that. So this system recently went in. This was a fire station in Los Angeles County. So this would be typical of a good application for Puraflo, where obviously the people, the first responders, don't need to be babysitting their on-site system, and they don't need to be smelling it, and they don't need to be worrying about it even being there. And so Puraflo is a great choice for those kind of applications. Peat obviously is a natural odor filter, so Charlie and I have worked for the company for over 8 years, and we've never had an odor complaint in all that time, and that makes sense because with peat you're not going to. But this offers them, this has pad dispersal, so this offers them a very simple system to maintain and one that they're not going to have to worry about. So my understanding, and Tanya can jump in here, but I think there's some more of these systems under design in other fire stations in LA County. Is that right? I don't know if she has access to speak or not. But anyway, Tanya,
yes, can you hear me?
Yes, we can.
Okay.
Yes, there are some other systems that are going to be
excellent.
designed.
We have more of these on the way in LA County.
Yes.
This is an interesting one. This is up in northern New Jersey and kind of the mountainous areas, what they call the tri-state area. So this is a mobile home park that was put in 40 years ago. It actually was a decentralized system. They had conventional septic systems in different sections of the mobile home park. And then what's happened is over time, as those have failed, they have very limited area because it's all built out. The mobile homes are very, very close to each other. And they get vacations. It's a very isolated spot. They get vacationers from New Jersey, New York, and Pennsylvania. So this will show you one that's a commercial pad, Puraflo with pad dispersal. So this is under construction. So this is just one part of the mobile home park. But here you see the treatment and the dispersal field for that part of the mobile home park. And here's another section. So this would show you, obviously they would plant grass over this and landscape it, but this shows you the finished site photo prior to landscaping. And then here's one that actually is landscaped. This is, obviously the grass is brown because it was in the fall, because you see there's no leaves on the tree, leaves on the trees. So this is one, and what's interesting about this is when you look at hydraulics from a soil perspective, this one you can see is actually stepping down the hill. We would have actually recommended rotating the modules 90 degrees so that the length of the module was on contour, but we were out at this site, we were walking way down the hill where it slopes off, tapers off on those last modules. And so this just, one of the things we often deal with is these very, very tight sites that you just don't have a lot you can do with them. And one of the great things we've seen over the last 22 years is we don't have surfacing effluent issues. And we look for them because when we see these sites in the soils, you get concerned about where's the water going to go. But because of the time dosing and the peat tends to be like a sponge and we slow weep that water in, we've seen very positive results even in tight situations like this. And this is just another section of the park, and it has a laundry facility off to the right that you can't see. Okay, so one of the things we like to say about Puraflo is we like to call it like the most versatile treatment. You can do it in single pass mode with septic tank effluent. You can do it in recirc mode with septic tank effluent. You can do both of those past another aerobic treatment technology. So if you want to get further treatment behind another type of technology, we do that routinely, where it becomes a polishing filter for another treatment technology. And this is a project we work with Jensen Precast on up outside of Reno, Nevada. It's actually an Apple data center. and it actually used our platinum technology, which is a submerged aerated filter, and then it has 12 Puraflo modules following it that part of them recirc back, because you can actually see that recirc line just below the platinum tank, recircs back to the wet well that's ahead of the platinum unit. So this is a case where we were going for very high level denitrification because that was the only requirement that the state of Nevada had for it. And this center serves about 45 employees. And any of you Apple users, this is where all your data is probably being stored. So this is another one just to show you. This is a really neat project up in northern Manitoba. So this one's 4 hours north of Winnipeg. So any of you that are in mountainous regions of California where you have snow and freezing, it's a non-issue. We have systems all over northern climates, northern Minnesota, Canada, and we don't have issues with the freezing. But this camp had an existing system that was causing issues with their water supply. And so the Manitoba Conservation, which is the agency responsible, actually mandated that the final treatment step had to be Puraflo Peat filters. And so you can go to the next slide. And this will just show you, this is another polishing filter situation. We're not going to show you it's an aeration system like the platinum. Actually, it is platinum. But this shows you the soils, and keep going to the next slide. And this one's actually a mounded pad. So you can see when they constructed it, if you look in the foreground there, you can see all the water just kind of standing in the soil. So you get in some of these areas, it's just very, very tough soils, high water tables. But that's a mounded pad, so you can see the sand, and then above the sand is some gravel, and then the 15 or 16 Puraflo modules that are there, and that is in polishing mode past an aeration system. So one of the other great things we have are these Excel design tools. I think it was 78% of the people said they wanted to know more about design tools and those types of things. So this is just a short list of all the different Excel design packages that we have. Of course, we have them for Puraflo. Like I mentioned, you could design a system from start to finish. We have water mounting sheets. You can use them not only for our technology, but you can use them for really any type of drain field. So those are very helpful. We have total nitrogen calculation spreadsheets. If you get into a situation where you have intermittent use, like Charlie and I are sitting at a Christian church camp here today looking at their old system, and they obviously are here during the summer, they're not here during the winter, and they even only have campers a few times a year, so in the summertime in between they have some down periods. And so we have to show how it's very helpful to show and characterize those flows and how that works, and so we have tools for that. The picture that you see there is one of the commercial design tools that we have. And then we have what we call the coagulator for the quaternary ammonium compounds, which if you get into treating restaurant waste or convenience stores, those type of things, we want to see a prediction on the quaternary ammonium sanitizer, because in low levels that'll have an impact on the system. So we have numerous Excel design tools available, and the whole goal is these have all derived out of questions that designers and regulators have had over the years. And so we developed these to try to build on what we've learned, what people have asked for, and the whole goal is to try to make everyone's life easier in terms of being a practitioner in the industry.
Colin, we have a couple of questions before we go to our next poll. The first one is, what is involved in replacing the media after 15 years?
Yeah, so it's a pretty simple process. You got to pull everything out. It's both the peat fiber and the gravel in the bottom. So typically that's done in two ways. Either a vac truck comes out and sucks it all out, or people pitchfork it out and then dispose of it in a landfill. And so then you just replace the gravel, you replace the peat, and that whole process is it's pretty simple. We have a number of systems in Virginia that are really, really old, and so we're kind of getting into that process now. And Virginia actually developed a policy with DEQ that actually went all the way up to the US EPA, I believe. And so you can actually bury the spent peat on the property as long as you meet the horizontal and vertical setbacks.
The next question is kind of two-part. What is the typical range of cost for the Puraflo system for a 3-bedroom house? And then what is the typical range of cost for the leach field system for a 3-bedroom house?
Okay, so I guess Tanya and Mike, if you're on there, because we talked about California and what the pricing you're seeing out there, we tend to default to our distributors on that one. So We'll let Jensen answer that question.
I'll jump in here. This is Mike. Typically for a 3-bedroom house with septic tanks, delivery, and all of that, you're looking at somewhere around about 11.5 for a 3-bedroom house. That's, like I said, taxes, delivery, tanks, filters, and that would be a pad dispersal system. The cost of your drain field would completely depend on what you're doing. Obviously, a perforated 4-inch pipe system with gravel would be the least expensive, up to a drip system, which would be the most expensive. But like I said, if you do a pad dispersal, you don't worry about that. And those drain fields that I mentioned can go anywhere from $1,500 up to $4,000 or $5,000, depending on the complexity. If you get into drip fields and things like that.
Yeah. So the gravel pad, obviously, it's just the cost of the gravel, and then it becomes a function of how difficult the site is to shoehorn it in there. So, we work on some very tough sites where you don't have a lot of operating room, but if it's a standard site like new construction, usually that's not a big deal.
Great. Thanks for answering those questions. We've got one more poll, and I'm going to put that out there now. And the poll is, or the question is, how receptive is the local regulatory agency to considering reuse system designs? So I'm going to launch that now and give our attendees a few minutes to respond to that. Okay, it looks like everyone has commented. And we have 0% saying they're not receptive, 60% saying somewhat receptive, 30% very receptive, and 10% extremely receptive. So that's really interesting.
Yeah, excellent.
And we do have another question, and then I'm going to open it up to our other attendees to ask some questions. The question is, what are the requirements of replacement of the septic system parts, including biofilters, and does Jensen do the repairs and replacement? Mike, you want to take that?
Can you read me that question one more time?
Absolutely. What are the requirements of replacement of the septic system parts, including biofilters? And then does Jensen do the repairs and replacement?
Jensen does not do the repairs. We're a supplier, and we can advise on design and install and train installers and things like that, but we do not do the installs ourselves. We rely on local contractors to do that. And as far as requirements, your pump can last anywhere, upwards of 20 years. That would really be the only moving part in a system like this. So other than the media replacement that has already been talked about, there would really be no other requirement. And typically a pump is, $400 or $500 and can be replaced very easily with the splice boxes and things positioned as they are in these systems. So really it would be a matter of ongoing maintenance, would be more a matter of checking the effluent filter in the first tank, as mentioned before, once a year or depending on use, cleaning that off. It would be very rare that you would have to replace pumps or anything like that. And then again, the modules themselves, the biofilters themselves, if were to go wrong with them, the media could be replaced, again, as we already described, and the boxes, quote unquote, themselves don't have to be pulled out and replaced. And I think Colin hit on what the pads had looked like underneath the system. So in many cases, if you're replacing the media, that is indeed the circuit breaker, and whatever failure condition is happening there, and the pads are essentially still clean and free of biomat and things like that, and can be used again once the new media is replaced.
Right. So we've had, thanks Mike, it's a great answer. We've had systems obviously that had the peat replaced at 20 years old, and they've gone back into the same plastic module that it came in. So they're very robust. I mean, I honestly have had, I live in Texas, and where it's very hot, a lot of sun, and I've had 2 modules sitting out in my yard for 8 years now. They don't have any cover. They're exposed to full sun year round, and they have not deteriorated at all in 8 years, and that's with full-on UV. So we haven't had any issues at all. The only issues you ever see, we had a couple lightning storms in Virginia, knocked some trees on them, and usually those have been lid replacements. So we haven't seen that. And if anybody's interested and wants to email us, we actually had a system where they cut out the bottom of the module in Maryland a couple years ago, and so you can actually see the drain field beneath it. And basically the gravel looks the same as the day that it went in 20 years previously. And the county regulator is the one that actually sent us that information. So
We have a couple more minutes. I know we were a couple of minutes late getting started today due to some technical difficulties, and I want to make sure we do cut this off at noon, as we promised we would, but we do have time for a few more questions. And if you would like to raise your hand, I can unmute you and you could ask your questions directly. Otherwise, you can just type them in or chat them in. We do have another question that just came in. Can the existing location of biofilters be reused if the area is no longer percolating?
I'm not sure I understand what they're asking exactly there. Like if you have like a standard conventional trench that is clogged up, and then you want to put the peat filters on top of it, the Puraflo on top of it, is that what's being the question?
Elizabeth, I'm going to unmute you so that you hopefully you've got your phone or your microphone on if you would like to clarify that question, or you can just type it in. You are unmuted. I think she might not have her mic set up.
Well, the answer is if it's actually an existing conventional field that's clogged up, it depends. The answer is it depends. So, if it's a soil issue or a water table issue, there may be issues there. If it's a biological problem that the drain field's all clogged up with bioslime and snotted up, so to speak, then yeah, we know that if you put aerobic effluent back in a clogged conventional field, that biologically it will recover that, and the soil will start accepting effluent again.
Elizabeth has just clarified that a little bit. If after many years of usage of the area and it is saturated, can it be reused?
If it was a Puraflo system that was there, or I guess it's in a repair situation, or just if you put a Puraflo system in and 20 years later it was all saturated?
I'm assuming that's what she's asking, yes. Yes,
yeah,
that's what she's asking.
Okay. Well, yeah, we typically don't run into that. So part of the design process, that's where you got to make sure that you don't run into those kind of conditions. I mean, in all honesty, we deal in very extreme sites, very tight soils, high water tables, and we don't run into those situations. But the answer would be, if the soil is saturated, it's not accepting effluent, I don't care what the treatment system is, whether it's Puraflo or anything else, if it hasn't been sited properly and you have issues there, then there would have to be an evaluation on remedying that situation. It might be I have seen situations where they raised the modules like 6 inches. They actually missed the water table. It was more shallow than they thought that it was. And so the gravel would be sitting right on top of the water table. And so they've raised it up. I've seen them where they've raised it up 6 or 12 inches, and then it's been fine after that. So that would be a situation where you could do that.
Ryan's had his hand up for a while, and Ryan, I will get to you, but Art has a question. In the meantime, at the live seminar in Reno, you mentioned an Arizona homeowner who was going to use land application. What is the status of that?
Like surface irrigation or with the spent peat, like surface irrigation from the effluent?
Can you clarify that, Art? Art, I'm going to unmute you and see if you've got your mic open. Surface irrigation.
Oh yeah, we have a number of systems, two different scenarios. It wasn't a system in Arizona. I mean, we have some sites in Texas that use spray irrigation, and we have sites in Ohio that do what they call direct discharge. So the effluent goes, from the Puraflo out to a roadside ditch basically, or a tributary. And then in West Virginia we have a number of surface discharging systems too. So we've been involved in a number of projects that surface discharge, and the standards are very, very tight. So
I'm going
Well,
to.
if I could jump in here quickly.
Sure.
The project that we do have in Arizona is for a Family Dollar store, and what's happening there is they had an evapotranspiration bed because in western Arizona, obviously dry, they don't have a lot of percolation there in this particular case, so they were going to do just a typical evapotranspiration bed. And when we went around and took a look at the existing ones in the area, it was obvious that they had been overflowing for years. And so what we proposed to the company was, instead of just putting in an evapotranspiration bed, they would install the Puraflo modules in the evapotranspiration bed, and then the water that was being evaporated off this bed would be treated and cleaned, as we've already talked about, and that way it would facilitate the evapotranspiration. It would, in the case of a breakout, would prevent untreated sewage or effluent going out into the surrounding areas, which was obviously happening when we were on site. So although it's not quite a surface, they had talked about in that project using it for surface irrigation in some of the community areas, but since then, and going through the permitting process, it's backed off. They aren't doing that mainly because the owner didn't want to spend extra money for the pumping and things like that. But it is going in as an evapotranspiration protection device, kind of a circuit breaker like we just talked about.
and one thing is we just got an inquiry in. So one of the questions that comes from California, we had an inquiry about using peat for the gray water. So we've done gray water treatment with the biofilters. Typically that would only be one module. And so I had an inquiry in where they wanted to use rainwater harvesting, gray water treatment, and also they were doing some hydroponics. And so they wanted some of the water coming off the hydroponics, and they wanted to commingle that in a tank and have that be treated and then use that, for like subsurface irrigation in the yard or whatever. So the answer to those type of scenarios for us is yes, all of the above. I mean, we are all about the water and bringing back clean water to people. We have the Puraflo is one of the systems. Fortunately, you have flexibility whether you want to do gray water, houses, septic effluent, aerobic effluent, all these different scenarios. We can do it all and make sure that people have their water back.
Ryan, if you're still there, I'm going to unmute you, but I just want to let everybody know because we are out of time. We will stay here and answer questions, and you can also email me if you have more questions and want one of our team to get a hold of you, and I'm happy to forward that information on. So, Ryan, you are unmuted if you remember your question. You've had your hand up for a while.
Yeah, no worries. Thank you. Hey, great presentation. I was wondering if you guys have run into any problems with UV, or if they have UV inhibitors in the bins or the Puraflo containers. Thinking, especially if it were going in some type of desert application.
Yeah, so it does have UV inhibitor in the modules, and I think there's actually one of the oldest systems in the West there's a residential Puraflo in Arizona. It's been there for I think over 20 years. And then there are systems in California that are over a decade old. And so, again, we have them in Texas. We've got them in, warmer areas like North Carolina and Virginia. And so, yeah, the modules do have a UV inhibitor in them, and it works very well.
Great, thank you.
Does anybody else have any questions? I don't see any hands up, and I don't see any questions coming in. If you do have more questions, again, please feel free to email me, and I will make sure that the appropriate person contacts you. Thank you so much for joining us today, and we've got another webinar scheduled in another month or so, and we'll make sure we get invitations out to all of you. We will also send a link out to this live recording as soon as it's available to me. So have a great day, everyone. Thank you so much for joining us.